Hi, my name is Maurizio and I am a senior data scientist at Ardigen. In this demo, I'll show you Ardigen phenAID, a web platform for drug discovery. It is a tool that empowers biologists to unlock the full potential of high-content screening campaigns, leverage complex multimodal data for deeper insight, and accelerate drug discovery through an intuitive, user-friendly, and data-driven solution. We start with the phenAID dashboard that lets you explore and manage your experiments, as well as check the progress on each of its steps. In the next step, you can view your experimental data in the plate layout view. You may also filter the wells by compounds, concentrations, or any other metadata that is provided in your setup. You can browse through wells and images, and if you want to see more information about a particular well, just click on its thumbnail. Here, you can see all the images in the selected well, along with the information about the compound, its chemical structure, and links to databases such as Campbell. You can zoom in and out on the image or manipulate image channels by turning them off and on or changing their intensity range. The next step, Compound Preview, allows you to organize and annotate the experimental data. You may search through your compounds and add a comment to each of them. Then you can simply select plates and wells for the analysis. You may apply the final metadata filtering to locate the wells of interest. You can apply the same selection for all plates or go one by one and have a different well selection pattern for each of them. The interface will let you know if a well is missing structural information. When ready, go to the next step, which is the analysis. In the analysis step, you define your task and the means to execute it by building your pipeline with predefined modules. Let's start with the segmentation to find cells in your images. Then, we will perform quality control to ensure the best outcome of the analysis. Blocks can be grouped to join their output, for example, discard images that failed multiple QC steps, or provide multimodal analysis by grouping features of different types. Some of the blocks can be tuned to fit a specific setup. You can modify their parameters, like the minimum number of cells in the image. From here, you can continue with the analysis or stop at simply performing the QC. For the next part, we need to decide which types of features should be used in the experiment. phenAID supports multimodal analysis, so you can simultaneously process features of multiple kinds, such as images and chemical structures, which allows you to leverage all of the available data. Currently, Ardigen phenAID provides image and molecular features which may be human-defined, like Cell Profiler for the images and ECFP for small molecules, or they can be generated by the advanced deep learning models trained by our team of experts. The most important step is choosing the type of your analysis. Right now, phenAID allows us to perform three kinds of these. Firstly, we have mode of action and biological properties prediction. They can be performed using uni or multimodal features. You can also perform virtual screening on an external compound library to find molecules that have the highest probability of inducing the phenotype of interest, defined as an image from one or more wells in the experiment. But in this demo, we will focus on the other modules. If some of the blocks are not compatible, the app will warn you that this kind of connection is not possible. Analysis may be saved for later use, and of course, once saved, it can be loaded back into the application. To quickly check if the pipeline works, use the test run option, which allows you to execute the analysis on a few manually selected wells. The test run shows detailed results of each step of the analysis, including segmentation masks, images which passed or failed the quality control, extracted features, and also the predictions for the selected wells along with probabilities of each prediction. When everything is ready, buckle up and click the Start Analysis button. Depending on the size of the dataset, the analysis can be quick or take a few hours. The app will display its status and inform you when the analysis is done. This is a good moment for a coffee break. Once the analysis has been completed, you can view your results in the Visualization step. Here, you can visualize and explore the results. You may easily define which kinds of visualizations you want to see through predefined blocks. just as when designing the analysis pipeline. Both the results of the analysis and the features defined in the previous step can be used in the visualizations. To set up a plot, choose a group of features and analysis modules. In each of the plots, you can take screenshots to use later on in the report step. The activity comparison plot allows you to select up to 10 compounds to visually compare their profiles. You can search for specific properties and filter by active and inactive ones. With scatter plots, you can analyze your experiment data in 2D space, inspect compounds, and find their neighbors. There is an automatic clustering provided based on the selected analysis. You can also compare your experimental data to the training dataset with embedded scatter plots. With tables, you can summarize your experiment's results. Once again, choose the feature group and analysis type for each selected visualization. Each table will show detailed information about the data. For example, with compounds in the cluster, you can list a given number of compounds starting from the center of the cluster by just selecting its name in the settings. The nearest neighbors table provides similar information, but this time the starting point is the selected compound. You can find neighbors in the experiment data or also include the training data by selecting the nearest neighbors in the embedded space option. You can examine the analysis outcome with prediction results visualization, which summarizes all predicted properties in a table. Finally, you can summarize your quality control in a table and filter the results by each selected block. For example, compare only images that pass the cell count block. As the last option, you can use the feature visualization. It allows you to either download features or find their location in the storage, as sometimes files can become too big to be downloaded locally, which mostly depends on how many plays there are in the experiment. In the final step, create a report using screenshots saved during the visualization step and add comments to your results. Here, you may also download the results generated during the analysis to share those with your team. That was a brief showcase of the capabilities of Ardigen phenAID, the most convenient way to use artificial intelligence in drug discovery. The application is fully customizable to meet your specific needs. It supports deployment in the cloud or on-premises. Our team is actively developing new modules to enhance functionality, including hit identification, lead optimization, library design, and more. Additionally, we provide data analysis as a service, and our latest models are already available for analysis of your data. If you are interested in seeing how you can use Ardigen phenAID in your analysis, please visit ardigen.com and book a time slot with our team. Let's talk about how Ardigen phenAID can boost your drug discovery process.